please welcome Regis. I don't know how to say it exactly. Say your name.
I'm Regis.
Regis.
Yeah.
Okay.
Thanks. It's awesome to be here. It's the second time I'm coming to the conference. It's sunny outside. It's California. It beats France any time of day. In France right now they have a thunderstorm, and there's the Euro which just started out. So yeah, perfect time to be abroad and to talk about code and stuff. So great time to be a software engineer. So who here is a software engineer? Like, yeah. Oh, that's a lot of people. Cool. That's cool. You guys might actually understand some of that stuff. Who's a Django software developer? Django, yeah, so many of them. And who is like an OpenEdX developer? Okay, yeah, that's good. For the others, well, I mean, you are important too, I guess. But there might be some stuff in there that you will not completely understand. The video will be on YouTube, and the slides will be available on GitHub, so I encourage you to review them afterwards. And that's my notes, which is awesome. So what are we going to talk about? Yeah, and this, by the way, this is my employer. I work for the French government. I know that sounds a bit boring, but so I'm here with, it's not actually, it's a pretty exciting project. I work with 3 other developers, including Richard and Sylvain, who are here at the conference, including Sylvain with right there. We produce more than 350 courses to more than 700,000 users. It's based on OpenEdX, and I love OpenEdX, and I actually spend a lot of time inside the OpenEdX source code, and that's actually what I would like to talk about here today. So the source code of OpenEdX is pretty much the raw material of OpenEdX. It's pretty much like the concrete or the glass in a skyscraper. So I feel like there's a lot of publicly available documentation on how to configure, how to run, and how to use OpenEdX, but there's very little documentation on the actual source code. So to understand the source code, you have to actually read it, and that's what we're going to do in this presentation. So let's get started with a high-level overview of yes. Let's get started with a high-level overview of the OpenEdX source code. I'm going to do that. We'll have to be standing here. I'll try with a mouse. Huh.
You want me to click slides for you over there?
Yeah, sure. Okay. It's the right arrow. Okay. Okay, just worked. So OpenEdX from above. OpenEdX has multiple repositories. The most important one is the edX platform repository. Then there are a couple other repositories, including the CS command service, which is Ruby code for the forums. The others are not really necessary. The programs repository and the e-commerce repositories are actually seldom used. You may customize your OpenEdX instance with themes. And of course, there are all the dependencies inside the virtual environment of edX platform. So I would like to take a look at the first one, which is actually the biggest, edX platform. So how big do you think is edX platform? Like, how many lines of code? I'm talking here about code written at OpenEdX, non-vendor code, and including tests. So, and this is a comparison of other pieces of software. So how many Django's do you think there are in OpenEdX? Like, Django is 1 DJ. So how many do you think? Come on, don't be shy.
1 Django.
How many one? 5 Django's? 50 Django's? 1.5? You're pretty close, man. Pretty close. It's actually It's actually 1.8. 87 Django's. So it's more than 427,000 lines of code. This is huge. This is pretty big. It's the biggest Django project that I know of. It's way bigger than Sentry. It's bigger than Flask, of course. I couldn't think of any larger project. The Python implementation is only 967,000 lines of code. So it's huge. So why is that important? Well, it's important for me because when I started this presentation, I thought, yeah, sure, I'll read the OpenEDX source code. Yeah, no big deal. That did not happen. And of course, we're not going to spend our time reading all the source code in this presentation. We're going to have to focus on the key parts. And I mean the tricky parts, the parts that are most difficult to understand. So actually, most of the code inside edX platform is a pretty standard Django code. We want to avoid that standard code in this presentation. So let's take a look at what is edX platform actually made of. No. Here we go. So it's not very surprising. edX platform is mostly made of Python. And then there's a lot of static files, static web files, JavaScript, CSS, HTML. You can see there's 10% of Sass code and 3% of CoffeeScript code. This is the code that takes time to compile when you build the assets, when you're building OpenEDX. So let's dive into this. And I'm actually going to have to need the mouse here. So is this going to work? OK, so edX platform is made of 400,029. Yeah, that number changed a bit because I added a test repository, a test folder. So what can we see here? edX platform is pretty modular. There's the LMS, the CMS, and the common code, which is stored either in common and OpenEDX. So for those of you that don't know, edX platform is actually more like two different Django projects, which are the LMS and the CMS. The LMS faces the students, and the CMS is used by the course designers and the course staff. The LMS is the largest project by far, much larger than the CMS. But actually, the common code shared between the LMS and the CMS is even bigger than the LMS. So the common code is 161,000 lines of code plus that 18,000 versus 170,000 lines of code. So it's pretty big. Let's take a look at the LMS. The LMS is divided in very modular apps. So it's pretty standard stuff for Django. There are many different apps. However, the CMS is made up of basically just one app called the content store. And the common code is the main app in the common code is actually the Xmodule library. And this is huge. This is 65,000 lines of code. So it's enormous. It's even if it were taken out of edX platform, it would be a very big project in itself. So we see a lot of test coverage here in pink, lots of JavaScript code, as I mentioned, in green, and the spec is also some test code, and yeah, that's it. So we've seen an overview of edX platform. Let's take a look at the dependencies of edX platform. No, that was a focus on the other parts. Yeah. So as I mentioned, it's wrong to assume that OpenEDX is just one big repository. There are many of them, but edX platform is actually the biggest by far. E-commerce is pretty big, but it was not written specifically for OpenEDX. Let's take a look at the dependencies inside the virtual environment. What do we have in there? Aura 2 is pretty big. We have many Xblocks. Xblock Poll is an Xblock. edX Search, I believe, is one. edX SGA is one. Rate Xblock, Asset Xblock, etc. So a lot of Xblocks. What can we see here? Many Xblocks are between 2,000 and 3,000 lines of code. That gives you an idea of how complex it is to actually build an Xblock. So as I mentioned, Aura 2 is huge, but Aura 2 actually contains a lot of test code and a lot of JavaScript code. So I estimated that there are less than 10,000 lines of Python code actually in Aura 2. All right. We've seen an overview of the edX platform source code. And yeah, that has taken a bit of time. I feel like it was necessary to understand which parts of OpenEdX are the most complex and where we're going to spend the most time when we investigate the source code. So what I would like to do now is to actually dive in OpenEdX and see how the sausage is made. And for that, we're going to view a course. So what I did for that is that I downloaded the latest release of OpenEdX in a virtual machine. So everything we say, and actually everything we said before, concerns Dogwood 3. So I booted up this virtual machine, started an LMS, and we have a browser running. So here we go. Let's take a look at a piece of the courseware. Here we see a section in the courseware. And you see that URL there. We're going to follow that trail. This is pretty much what Django developers do all day. This URL brings us to the routing file of the LMS. And you see this regex matches this. And this tells us that we should go to the index view from the courseware application to understand what is the code that generates the page at this URL. So let's go there. Let's take a look at the code inside this index view. Here, what we see is pretty interesting. First, we load the course that we're trying to see with the getCourseWithAccess function. And then we load the section module that corresponds to that course. OK, what is the type of the course object here? That's good. You're good, man. So we're going to take a look at the base class of course. For that, we print the class and all the base classes of the course object. So that's a lot. You're going to see the slide a lot. So as you, sir, mentioned, the base class of the course is a course descriptor with mixins. And it comes from the internal module of the Xblock application. This is very surprising, because if you go in there, in the internal module of the Xblock application, you're not going to find a class called course descriptor with mixins in there. So what are you going to find in there? Where is that coming from? Yeah, just to recap. So we followed that trail. We took a URL. It brought us to a view. And we found the course. And this course is a course descriptor with mixins. And it cannot be found anywhere. So actually, this class, is that clear for everyone? What is a mixin? Like when we say course descriptor with mixins, do you know? OK, so who knows what's a mixin? Don't be shy. You guys go to McDonald's? Yeah. So I asked around my developer friends if they knew what's a mixin. And actually, very few people know about this. It's something that's very popular in Python and less so in other languages. Let's give the definition by Wikipedia. So in object-oriented programming languages, a mixin is a class that contains methods for use by other classes. This is a bit abstract, so to say. So let's take a look at an example. Let's say you have a shape base class with edges and a method called a perimeter. And you inherit this class with you define two other classes, square and triangle. And you want to define a new feature, which is coloring. How do you do that? You don't want to bloat the definition of your classes with the coloring feature, because you don't need coloring for all classes. So what you do is that you create a mixin that provides just this piece of feature. And if you notice that this class does not work by itself. This is why it's popular in Python, is because, and not in other languages, this wouldn't compile in many other languages. Because self.edges does not exist in this class. But you can create a colored square class that inherits both from color mixin and square, and you have both functionalities. So now we know what's a mixin, so we kind of expect what we're going to find inside a course descriptor with mixins. If we go back to the base classes of course, it's also a course descriptor. And here we can see a kind of a pattern. So how actually the course descriptor with mixins is dynamically generated. Yes. It's dynamically generated by a class called the mixologist. The mixologist is instantiated by, and when you pass arguments to its constructor, it defines the underscore mixins argument. And when you call the mix method on the mixologist object, it creates a new class with base type the class that you pass to the mix method. It adds the name with mixins, and it adds also all the mixins that you passed at instantiation time. OK. And this is actually what creates the with mixins classes. At first, when I Googled mixologist, that's what I found. I was wondering if it was a frequent design pattern. It isn't. Cannabis cocktails. Anyway, yeah. OK. And this mixologist class is used in OpenEdX in this file, and this is where it generates stuff with mixins objects. And the argument that is passed to the constructor is actually a setting called Xblock mixins. Aha! So what is the value of this setting? We just follow the trail and go to the settings file. Here we see the Xblock mixins setting. It's pretty much the same for the LMS and the CMS, except that the CMS adds authoring mixin. And this is a pretty cool feature because it means that you can add new features to your Xblocks just by modifying this setting. So it's pretty awesome. It's usually done when you want to add new fields to your Xblocks. Because and that's pretty much what these classes here do. So actually, this piece of code in the settings file is preceded by a comment. And here it is. These are the mixins that should be added to every Xblock. This should be moved into an Xblock runtime application object once the responsibility of Xblock creation is moved out of module store. And if you're just a Django developer, this is all Chinese to you. This raises multiple questions. So what is an Xblock? What is an Xblock runtime application? And what is a module store? Now, I know this is the OpenEdX conference, and we're going to talk about Xblocks all the time. OK, so who knows here what is an Xblock? That's a lot of people. OK. Who knows how an Xblock is instantiated? One guy there? Two guys there? OK, let me ask you guys, how is an Xblock instantiated?
At runtime by the X module system.
OK, that's good. I have a bonus question for you. Are you sure?
Also depends on the type of Django application the Xblock is built on.
Pretty much, yeah. You're getting close. We're going to talk about that a lot. Thanks, man. So let's try to answer these questions. Yes. OK. So here there are many different types of general explanations on Xblocks. Here are two of the explanations that I think are the best. Both are by Ned. This one is very short, but it's very clear. And this one is pretty recent. It was done during an Appsemblers webinar. And it gives you an overview of Xblocks. But it doesn't tell us really what is going on inside. So We all know about Xblocks. A course is an Xblock. Course components are also Xblocks. It's Xblocks all the way down, as Ned says. So there are many examples of Xblocks, as I mentioned. There's the course, of course, the poll Xblock. You have Xblock for peer assessed exams. You have a molecule editor in JavaScript. And you have many of them to build fun and interactive courses. There's actually an Xblock directory. It's located at xblocks.org. It's not at xblocks.com. That's a quilting website. Don't go there. It would make things very confusing. OK, so it's Xblocks all the way down, as Ned says. So let's try and take a look at this. I told you you would see that slide a lot. And as expected, the course object also inherits from the Xblock class, which is good. What am I going to say next? OK. So I want to take some time to actually analyze an Xblock. And for that, I want to take an example, which I think is very clear and concise. It's the Xblock poll Xblock. It was designed by OpenCraft, and it's available on this GitHub repository. So let's take a look in there. The poll block class inherits from the Xblock class, which is good. It has a studio view, which presents HTML code for the course staff. Here we see that the studio view actually returns an Xblock fragment. Xblock fragments are interesting, but they are very easy to understand. I encourage you to take a look at that. It's basically some HTML code with dependencies, JavaScript, CSS dependencies. And we're not going to talk about that a lot. More interesting are the fields attached to the Xblock. Here we can see that there are two fields. I just listed two of them. There are many others, answers and choice. So this is a polling Xblock. So there's one, there are multiple possible answers presented to all the students, and every student has one choice. We can see that there's a scope attached to each field. We're going to talk about that later. And what does that make us think of? It kind of reminds us of Django model fields, but it's actually pretty different. In Django, fields are attached to a model instance thanks to meta classes. Here, field values are attached to an Xblock at runtime, so it's really different from Django. This is a bit abstract. Sorry about that. Just remember that this looks the same as Django fields, but it's actually the implementation is completely different and much clearer, in my opinion. The poll block wants something called settings. And this settings thing is actually used in the image alt mandatory method. Here we can see that it tries to access a service of a runtime. And this service is called settings. And it uses this service to do stuff. And this brings us to the second question that I mentioned earlier. What is a runtime? And what does a runtime do? Essentially, a runtime does two things. It actually instantiates Xblocks. If you take a look at the constructor of Xblocks, it takes a runtime as a first argument. And it's actually the runtime, when it instantiates Xblocks, that passes itself to the Xbox. So you were good, man. And then the runtime also has a construct Xblock from class method that calls our bartender friend here. Second responsibility of runtimes is to provide services to Xblocks. And so we've seen an example of these services. For instance, we've seen the settings service. And actually, a service can be anything. It's just basically a Python object, and you can do anything with it. You can call methods. You can, I don't know, do whatever. And this is pretty cool. So because Xblock are supposed to live independently of your platform. It's not supposed to import modules and all. It's just supposed to call services from your runtime. actually, there's one service which is extremely interesting, and it's the Xblock serialization and deserialization service. It's called the field data service. So let's take a look at that. So, because we haven't seen yet how Xblocks are stored. We don't know how they are stored in a database or in MongoDB, right? Anyway, so let's talk about serialization. So the Xblock inherits from the scope storage mixin. The scope storage mixin needs the field data service, and the field data service is actually used inside the for safe fields method, and we call the setMany method on that field data to actually serialize the Xblock to disk. This is for writing. So we don't know what a field data service is, but we know that it needs to expose a setMany method. So this is for writing. What about reading? Reading is actually done inside the field class of the Xblock. Here, reading is done by accessing the has method and the get method from the field data service. So we know that the field data is supposed to expose at least the get, the has, and the setMany methods. And actually, the field data class is defined in the Xblock library, and this is the entire implementation. And if you create a field data service, all you have to do is create a get, set, and delete method. And the has and setMany are actually wrappers around get and set. So this is all very interesting, but that doesn't tell us anything about where Xblocks are actually stored, right? So let's recap a bit things here. So course components are actually things with mixins, and they are also Xblocks, and they are instantiated by a runtime that has I don't know what's coming. A field data service that stores data, and we don't know where, actually. So let's try to investigate this a bit. Let's see how Xblocks are stored. This is the implementation of the field data service used in the LMS in OpenEdX. So what do we see here? The LMS field data service actually stores stuff in different places, in two different places, either in authored data or in student data. And it depends on the scope of the field. I told you we would come back to the scope of the field. Remember the poll block, each field has a scope. And that's where it comes from. Scope settings. So in this example, the choice that you give to each user is the same for all users. So it's only going to be stored in one place for all users, whereas the answers for each are different for each user. So you're going to want to store one example for each different user. And this is why these answers, scope settings. Actually, the answers is the possible answers. Yeah, so you're right. I said that. The slide is correct, but I made a mistake. I explained that. So the choice is actually user-specific, and the answers are generic to all users. And these two things are in different places, and it's actually stored in two different databases. So where? So that's my definition of the field of an Xblock, the scope of an Xblock field. It defines a set of Xblock instances over which the field takes the same value. So I don't know if that makes it clear to you. So let's talk about the student data. The student data is actually stored in the key value store managed by Django. So this is actually MySQL. And perhaps you've heard that student data is stored in MySQL, while author data is stored in MongoDB. And this is where it comes from. This is where this distinction comes from. So this is done inside the module render module for the courseware. What about authored data? Authored data is actually configured thanks to the module store setting, and this you can modify. The student data, if you are the administrator of an OpenEdX platform, you cannot choose where you store student data. It has to be in MySQL. Whereas the authored data can be stored in many different places. It can be stored in MongoDB, in XML files, in MySQL, and it can be stored in split draft things. Yeah. So you have a choice, and which is great. Phew. Okay. So that makes things a lot more clear, right? So we have Xblocks, which are instantiated by Runtimes, which provide services. And services store Xblocks in either MongoDB or MySQL, and it's all easy. You understood everything, right? Okay. Except that, why that setting there? Why is it called a module store? If we come back to the questions that we asked earlier about that comment that we saw in the settings, we asked what is an Xblock. We actually answered that. We asked what is an Xblock runtime application. We answered that as well. The runtime instantiates Xblocks. And what is a module store? So we have to actually dig deeper in order to understand that. The X Wars. So it wasn't actually a very long time ago. It was only just a couple of years ago. It was 2013. So the Xblock library was created at the end of 2012. And that's after OpenEdX was created. So when OpenEdX was created, there was no Xblock. OpenEdX was relying on a different system called Xmodules. And it's only later, that's early 2013, that edX platform started to migrate from Xmodules to Xblocks. And this is the first commit that introduced Xblocks. The thing is that OpenEdX maintains backwards compatibility. So we had to, OpenEdX had to stay backward compatible with Xmodules. Yeah, I didn't want to talk about this. This is how I found the commit, basically a git bisect. Anyway. So let's talk about Xmodules. This is kinda deprecated. So apologies if I make any mistake in this. If I do, please ask in the question session or mention that later to me, and I will update the slides on the internet. So how does an Xmodule work? It's actually quite different from an Xblock. Xmodules live two lives. First, they start their life as an Xmodule descriptor. They are instantiated by a module system, and they take their data from a module store. But an Xmodule descriptor doesn't have any data associated to a student. It only has data associated created by an author. So in its second life, the Xmodule descriptor becomes bound to a user. It still takes its data from the module store. It's still instantiated by a module system. It also takes student data from the module store, and it becomes an Xmodule. This is great, but this is not compatible at all with Xblocks. As a reminder, this is how Xblocks work, at least in the Xblock SDK. As we mentioned, Xblocks are instantiated by a runtime. They have field data both from authors and students, but it all comes from the same place in theory, and it all comes at the same time. That's the important part. So this is how it works in theory, but it doesn't work that way in OpenEdX, and this creates a lot of confusion. So in order to be backward compatible, OpenEdX had to adapt Xblocks to the way X modules used to work. And this is how it works actually right now in OpenEdX. So a runtime instantiates an Xblock with just authored data. And this Xblock is not really working very well because it doesn't have the student data attached to it. And then it attaches student data to that Xblock, and it becomes a fully functional Xblock. Whew. And this is how Xblocks works in OpenEdX. So now we have seen pretty much, we've seen how Xblocks work in OpenEdX. So what are the runtimes that are used in OpenEdX? There are two runtimes, one in the LMS and one in the CMS, essentially. The runtime of the LMS is actually called the LMS module system. You can see that it inherits from module system. So the old X module kind of runtime. In the CMS, it's pretty similar. The preview module system inherits from the module system. And the module system actually inherits from the Xblock runtime. So in OpenEdX, a runtime is both a runtime and a module system. So now that we understand how runtimes work in OpenEdX, we can try to add new services to them. Services, as I mentioned, are really useful, and you want to add them. Currently, there's no plug-and-play way to add services easily inside an LMS module system. This is how the LMS module system is instantiated. So you cannot really add anything easily like that. However, you could easily define a setting called something like that, and you would add runtime services, services at runtime, runtime services at instantiation. And that would be pretty much the same way that mixins work. All right, that's it for today. I don't have much in terms of a conclusion. OpenEdX is pretty big. I may have done a couple of mistakes. There are 3 of us here at the conference. If you feel like you want to talk about anything like technical, we're here to talk about it. That's it. Thank you.